This demo will show how to use SaskGlue to automate a build pipeline. The application we will use for this demo is a stock quote publisher web application. Technologies we will use in this demo include TypeScript, Node.js, Mocha, Python, RabbitMQ, MongoDB, Terraform, Docker, Kubernetes, and Amazon EKS and ECR. We're using GitHub as our code repository. This diagram shows the main components of the production system. We have our single-page web application connected to a backend API with Nginx. We have our stock quotes feed Python application, which is getting quotes from Yahoo. We are using RabbitMQ to push new quotes to the browser, and MongoDB to store subscription information. We expose the application publicly with AWS Elastic Load Balancer. The application components are hosted in Docker containers and deployed with Kubernetes hosted in Amazon EKS. This is the web application. To view quotes for a stock, we simply enter the ticker and hit the subscribe button. We now begin seeing regular quote updates. In order to fully test application changes, our build environment needs to look very similar to the production environment. However, we don't want to pay for compute to run the build environment when there is no build running. Instead, we want to automatically deploy a build environment when a new version of the code is pushed to the code repository. One difference you'll notice with the build environment is the SaskGlue agent, and we'll talk more about that later. Let's say we want to change our application, for example, to report the calculated weighted average price with each quote. We'll make the change and test it in our development environment, and then push it to our code repository. At that point, we would like the build process to kick off automatically. Since we want to deploy and run our build in AWS, the question is, how can we automate that build process since we have no direct connectivity from GitHub to our AWS environment? This is where SaskGlue comes in. First, we're going to create a SaskGlue job to run the build. This job will consist of 3 steps. The first will deploy the build environment. The second will run the build, including the unit tests. And the third will deploy the changes to production. Each step will be dependent on the prior step completing successfully. Second, we will configure a GitHub action to start our job via the SaskGlue API whenever new code is pushed to the repository. Let's take a look at our SaskGlue build job. We are currently looking at the workflow designer view of the job designer. We can see our 3 tasks: deploy build environment, run build, and deploy build. We have inbound routes defined for the run build and deploy build steps, ensuring that these steps only run if the prior dependency completes successfully. I can create or modify inbound routes by clicking on the inbound button on the dependent task and then clicking the route to task checkbox for the prior task, like so. So I can create or remove a dependency by checking or unchecking that checkbox. We can set a route code using a valid regular expression for dynamic routing. A blank route code is equivalent to success. Looking at the deploy build environment task, we can see that it's targeting an agent with tags Terraform equals true. This corresponds to an agent we have running on an EC2 instance in our AWS environment, which corresponds to this agent in our diagram. We will run the code that deploys the build environment with this agent. Let's take a look at the code that the agent will execute to deploy the build environment. This is a shell script that deploys the build environment to a unique namespace in our Kubernetes cluster using Terraform. If the deploy task completes successfully, the run build task will execute. We can see that this task is targeting an agent with tags demo equals build pipeline 1. This corresponds to a new agent that is dynamically created as part of the build environment, as we can see in our diagram. We're using the SaskGlue agent Docker image to deploy this agent. Let's take a look at the run build code. This is a shell script which clones the Git repo and runs the build and tests with the npmi command. We're setting the route to OK using the @sgo syntax for dynamically setting runtime variable route or runtime variable values, including the route. We can also see that we've set an environment variable named node_env to test, which will instruct npm to run our Mocha unit tests. If this task completes with route code OK, the deploy build task will run. Again, this task targets our agent running outside of the build environment, since it needs to have access to both the build environment and the production environment to deploy the new version. Looking at the code, this step runs a shell script which will log into AWS ECR, build the new stock quote feed image, and deploy it to the production environment with Terraform. Here we can see the GitHub action, which will kick off the build job via the SaskGlue API when we push the new version of the code. And it's using an Axios component available as a GitHub action, and it's calling the post method of the job endpoint, passing in the job definition ID, the team ID, an authorization token, and some other parameters used by the job. Okay, let's see this in action. Here is our stock quote publisher Python application. I've commented the previous code that delivered the quote without the weighted price, and you can see the new code that calculates the weighted price and delivers it with the raw quote data. I'm going to commit this change and push it to Git. Okay, so let's come back to the SaskGlue web application, and we'll look at the SaskGlue monitor. So here we can see our build stock quotes publisher job got kicked off, and we can click on the monitor link and it will show us the tasks in the job as they're running. We can see when the job kicked off, who started it, the current status, and we have the ability to cancel or interrupt the job. If we look at the details of the running task, deploy build environment, we can see the name of the machine where it's running. We can see the current status. Again, we can cancel or interrupt. We can see what time it started, and when it completes, we'll be able to see the time it completed. We can see the script that is executing, and if you'll notice, we're looking at the tail updating in real time. We can also see the full standard out by clicking on the standard out link. If there were any errors that occurred, we would be able to see them by clicking on the standard error link. Okay, so our first task completed successfully. So we've deployed our build environment. We can see it started at 257, completed at 258. We can now look at the run build task as it's running, and if you'll notice, it's running on a different agent name that seems to look like a Kubernetes pod name, and it is in fact running in a Kubernetes pod. This is our new agent that was deployed with the build environment. And again, we can see the running script. We can see the standard out, and the build process is currently running. It's currently transpiling the TypeScript to JavaScript. When that's complete, it will run our unit tests. If there were any errors that occurred, again, we would see them in the standard error box. This step takes a little bit longer to complete. Okay, the build finished and our Mocha test ran, testing the different API endpoints. And so our run build process completed successfully. So at this point, our deploy build process automatically kicked off when run build completed. And again, we can see the running tail and the full standard out. So what we did here is we built the new version of the Docker code of the Docker image, and we deployed it to our production environment using Terraform. So if we come back to our web application, what we're going to see is that Kubernetes will deploy the new version of our image using the rolling deploy process, which is kind of like in a relay race when there's a brief period of time when the baton is held by both runners. So at this point, we have the old version, which is delivering quotes without the weighted price, running in parallel with the new version that is delivering quotes with the weighted price. So we'll see this parallel execution for a period of time until Kubernetes spins down the previous image, which it has now done. And so now we're seeing all of the quotes come through with the weighted price. We hope that you have enjoyed this demo. Please visit www.saasglue.com for more information about SaasGlue, or send us an email at help@saasglue.com for more information. Thank you.